All right, 35. 35, you should have gotten A. So you might need me to go over 35. 35, 35, and you might need 35. Yeah? Okay. All right, so you see this little bitty triangle down here? You need to find out what that triangle is first, because then these two are vertical angles, okay? All right, so if this one is 140, it told you these three were on a straight line. So if this is 140, how much would this little angle right here be? 40. And now you can figure out if this is 40 and this is 80, how much is this little one right here? 60. And if this one is 60, these two are vertical, that means this one's 60. And if, there you go, this one's on a straight line, and so now you can figure out this one. How much is that? 40.
You can also figure out the G one because...
The G one, hold on. This one?
Yes.
Okay.
Because the, what is it called? The interior opposite thing?
Mm-hmm. The outside angle is equal to the other two added together?
No.
No? That's not what the one you're talking about?
You know the sliced bread thing?
Is that not like the thing that looks like the tip of the tail and then like this one is...
Like 1 is the 8, as 2 is the 7.
Oh, okay. I didn't think about that one. Yeah, you could do it that way. I didn't even think about that one. I thought you meant there's another one from geometry, the outside angle is equal to these two added together. So you could do it that way. But I didn't even think about it that way, Matthew. That'll work though.
What?
If you have a triangle, which you have this one right here. Oh gosh, don't pretend like that one's a good triangle. All right, once you found that this was 60, the outside angle is equal to the opposite two added together. So 60 plus what is 140? Or you could have found this one. You should have learned that in geometry. Oh, Lord have mercy. Yes. All right, 36. 36 you should have gotten K's. And you might need me to go over 36. You just plug it in. You plug it in. So 20. Okay, let's do 25 actually. No, let's do 26. I'm sorry. Blah, blah, blah. Let's see. Where are we at? So if we plug in 26, what's 26 minus 1? 25. And if you square root 25, you get 5. That's the only one there that would be closest to being greater than 5. The other ones would always be less than 5. All right, 37. Unfortunately, when we did this yesterday, you probably may not have known how to do it, but now you should know that changing degrees to radians, it means that 180 is the same as how much in radians? What was this? Nope, that's 360. What's 180? Just pi. Very good. So you see the only thing they did was change the 180 to a pi. Y'all remember that from yesterday? The 180 degrees divided by pi and the pi divided by 180 that we did yesterday? Got all that stuff? Alright. Okay, so 38. You should have gotten H. Does anybody need me to go over 38? That was also a geometry question. But I know it's been a minute. That's the distance formula. Anybody need that one? Yeah? Alright. So the distance formula is the square. Let me get that sucker out of the way. It doesn't matter which one you start with. Let's start with the x's. Negative 3 subtract 4 squared. And then you add the y's subtracted. And that would be negative 7 squared plus 6 squared. And that's 49 plus 36. That's 85. Which was H. Alright, what about 39? 39 you should have gotten C. You might need this one?
Yes.
Okay, you had to know the volume of a cylinder was pi r squared h. And it told you that the radius was 4. And the interior length, if you stand that up, that would be the height. So if you had a cylinder laying down like it is, if you stood it up, that would be your height of it, which is 25. And you plug it into your calculator. Pi times 4 squared times 25. And that is 1256. The closest one to that, because it didn't say which one is the volume, it said which one is the closest to the volume. And the closest one was C. Y'all okay? Alrighty. So, let's talk about a few things real quick. You ready? Alright. So, Friday. There's a lot of stuff going on Friday, okay? A lot of things going on Friday. If you're a junior or a senior going to prom, first and second period, they have someone coming in to talk to you about making good choices at prom and not doing things you shouldn't do. And then the afternoon, there is a soccer game. So we've got a lot of things going on. First thing is today we're going to finish up 12-3. So if you want to go ahead and grab those notes while I talk to you about a few things, you can. We're going to do 12-3 today. We're going to finish that stuff up. Tomorrow, we are going to have a project that we're going to do in class. It's very fun, very easy.
I feel like you say it's fun. No, it's fun.
We're cutting and pasting and gluing and doing unit circle. It's fun.
Okay, maybe that's it.
It's fun. It's not like project.
We get to color.
You get to color.
Okay.
Yeah, you get to do things like that.
Yeah, I'm learning.
I know it. So we'll do that tomorrow. All right, tomorrow, if you have, one second, Jeremiah. If you have, like the stick glue, or if you have scissors, please bring them tomorrow because I'm not sure if I'm going to have enough for everybody, and we're going to have to get this done tomorrow because then Thursday we will review, and then Friday will be your test. If you're not going to be here on Friday, you could either stay Thursday afternoon and take it, or you could come Monday and take it. Does that make sense to everybody?
Or Friday during a different period?
Or Friday during a different period. Yep, I will not be here during Friday. Because I'm getting LASIK surgery, so I will not be here. LASIK surgery, so I won't have classes anymore. So, anyway, it was supposed to be next Friday, but the doctor moved it. So, anyway, I had to take off another stinking day. So, that will be on Friday. So, in other words, Thursday, if you have any questions whatsoever, you need to make sure you tell me during class, or you need to make sure you email me Thursday night, because Friday I will not be able to see to answer any questions. So, does that make sense? Like literally, won't be able to see. All right. Y'all good? You got it good? All right, Matthew, what are we doing tomorrow?
Tomorrow,
Mhm.
we have to bring glue sticks and scissors because we need to finish it by tomorrow.
I'm so glad that you can multitask. I'm really, really awesome with that.
I was telling him
I know.
you took my charger.
All right, y'all ready?
Who's Max?
It was Max.
He took my charger 2 weeks ago.
Why are you looking at me? That's not my fault.
Yeah, that's not her fault. All right, here we go. You ready? So let's talk about this triangle real quick that we did at the end of class yesterday, okay? So in order to make a triangle, none of those sides can equal what number in order to make a triangle? In order to physically have a side, they can't be what? Zero. Okay, so none of those sides can be 0. Does that make sense to everybody?
Yeah.
Okay, so also, none of the denominators could be 0 as well. Does that make sense to everybody?
Oh,
So, x cannot equal 0 here. Y cannot equal 0 there. X cannot equal 0 there. Y cannot equal 0 there. Technically, the radius can never equal 0, right? But you're never ever going to have a circle that equals 0, so that's never ever going to happen. So we're not even going to worry about writing r cannot equal 0, because that can't happen to do what we're going to do. All right, so let's look at the bottom section, and that's all we're going to do today. You ready?
on the front, we have to write x equals 0.
Yeah, do we have questions like this?
No, you just need to know that it can't equal 0. Just know that it can't equal 0. But you should already know that the bottom of a fraction cannot equal 0.
Yeah.
All right, so are we going to memorize this? No. We're just going to know how to draw this pretty little picture on our test and know what sine, cosine, and tangent are. Does that make sense to everybody?
Wait,
Okay.
You said something else for us to remember.
We're not going to remember
No.
180 and the pi and 180 that we did yesterday. You're just going to know if you have a degree on top, that the 180 would go on bottom. That's not what you're talking about? Then I have no idea what you're talking
Some
about.
definition that you said was in the class.
Oh. So where do we get the circumference of a circle was 2 pi and 360? We got it from the circumference formula, right? So that's how we knew that 360 was equal to 2 pi. Because this 2 pi came from the circumference of a circle. Yes, that will be on there. That you need to know. Alrighty, let's look at number 1. You ready? Alright, so let's think about ourselves. We got 4 quadrants, right? What quadrant would -3 and -4 be in? So if I were to graph that, so you might want to draw yourself a little graph. How'd you get that? Because I would go left 3 and down 4, right? Does that make sense to everybody? That would be,
That's not right.
oh yeah it is.
You can't have a double negative in front of it.
Oh, Lord have mercy. Okay. All right, so that's where -3, -4 would be, right? Y'all okay with that? So we would draw our radius out, and then we would make our right triangle from that. Y'all okay with this? It's the same thing, but it's just upside down, right? All right, where would our theta go? Where does theta always go? Where's the vertex at that we talked about yesterday? It's not on your phone, by the way. It's where, Sarah? The origin. Very good. It's right here at the origin. Very nice job, Sarah. It's always at the origin. All right, now, ladies and gentlemen, which side is this right here?
Oh, that's an X.
That's the X, Matthew. Very good. Why is it the X? Because what axis is it on? And what is our X in this case?
X. Oh, -3.
-3. All right, what side is this one right here?
Y.
Why is that? Because it's vertical. There you go. It's with the y-axis. And what is our y in this case? -4. And what would be our hypotenuse right here? What did we call it yesterday? R. Very good. And you should know that if one side is 3, one side is 4, what's our hypotenuse? There you go.
Is it 5 or negative?
Which one is it?
It's going to be -5.
Positive 5 equals 2, negative equals
How'd you get 2 negatives?
-3, negative 4.
More specifically, how did we get that hypotenuse? What did we use?
The Pythagorean.
Pythagorean theorem, which multiplication means that they're squared, right? So 3 squared would be +9. 4 squared, -4 squared would be +16, right? Does that make sense to everybody? Not because the 2 points were negative, but because we squared them and they were positive. All right, so here we go. You ready? We need to find all 6 trig functions. Here we go. Sine of theta is,
Hold on.
which is?
-4 over 5.
Very good. And cosine of theta is? Am I going too fast?
Yeah, you're going pretty fast.
I wrote one number.
That's fine.
Matthew. Am I really going fast? Oh.
No.
Can I go now?
Yeah. -3.
-3 over 5. Very good. All right. Tangent of theta,
-4 over -3.
which is?
It's 4.
4 over 3. Very good. 2 negatives make a positive when you divide them.
Yeah.
All right. Now all you gotta do is find the opposites of them. So what's the opposite of sine? Cosecant, which is? Does it really matter where that negative goes? No. On a test, on a standardized test, you're going to see that negative where? There you go, in the front. All right, what's the opposite of cosine? There you go. What's that give you? There you go. And what's the opposite of tangent? Cotangent. Look at y'all. Y'all so smart. Is that 3 over 4? Y'all okay? Pretty easy stuff?
Pretty smart.
I know y'all pretty smart. Yep. This trig stuff's not too bad, right? It's a little different. Okay, let's do one more together, and then I'll let y'all do 3 on your own, okay?
Oh, you're so kind.
I know. Actually, I am kind, because 3 is a lot easier than 2. So, how do I graph -6, 2?
Like you go left and in the second quadrant.
Very good. You go left 6 and up 2, which would be in the second quadrant. Very nice. Very nice. Oh, I didn't leave myself enough room. Oh, well. Leave yourself more room at the top than I did. Whoa, what?
That seems up one.
Yeah. That seems a little bit.
Well, I needed to give myself enough room to get my triangle big enough I could write stuff in there.
Realistically,
Well, remember from geometry, you can never assume that your triangle is drawn to scale. Anyway, oh snap. Where is theta at? The origin. Very good. So right here is going to be theta. All right, what's this one right here? X. And in our case, X is -6. It will greatly benefit you to write those numbers down. Bless you. Bless you. Because if not, it's going to be a little confusing. All right, what's this one? Y. And in our case, it is 2. All right, now, this one's not so easy. This one's not one that you know. So we're going to have to use Pythagorean theorem, which most of you are already doing. So -6 squared plus 2 squared is equal to how much? Yep, So that'd be 30. I'm just going to write it for people that need it. But you are right. So square root it. Now, 40 can be reduced. 4 and what? 10. Very good. So that'll be square root of 4 times 10. And that will be 2 square root of 10. Why are we not doing plus and minus on these? I was such a stickler about those before. What can't be negative?
The radicals.
What are we dealing with? Any part of a triangle cannot be negative, right? You cannot have a negative side of a triangle. It's not, like physically impossible. All right, so this r is 2 square root of 10. Y'all okay? Huh?
Yes.
Alrighty. Kinda? Alrighty. Let me do this little line right here so we can keep these separated. Alright, sine of theta. You see now why I made my triangle so big so I could write everything in there?
How can you not have any side of a triangle being negative if x equals -6?
Because what happens when I square it?
Um,
It just means that, remember the negative angles and stuff that we did yesterday? It just means you go in an opposite direction. That's all that this negative means. Alright, so let's see. We got sine. What's sine of theta?
2 square root of 10.
Alright. So the 2's cancel out. So you have 1 over square root of 10. Have y'all learned the trick by now to rationalize in your head? You do have to square root the top and bottom, but it simply just comes out to be square root of 10 over 10. That's the trick. If you multiply by square root of 10 on top and bottom, that's what it comes out to be. Look, guys, you want to write all these steps because when I do cosecant, when you flip that, you're going to have to rationalize again. So if you write all these steps, you can look at your original piece because now cosecant, good grief if I can write correctly, what is cosecant when you look at your original one? It's just going to be square root of 10 when everything cancels out, okay? Y'all okay with that? Did I do too many steps in my head?
A little bit.
Okay. All right, so sine of theta was 2 over square root of 2 square root of 2. Square root of 10, right? If I were to flip that, the 2's would still cancel, and the square root of 10 would be on top. Does that make sense?
yes.
So you wouldn't flip the last one?
You could. You could. You'll get the same exact answer, but then you're going to have to rationalize again. You're just making more work for yourself. But it will give you the exact same answer, though. All right, so what about cosine? What's cosine of theta?
-6 so -2 square root.
There you go. So that reduces to -3 over square root of 10. If you multiply by square root of 10 on top and bottom.
Ms. Blackman,
Yes, ma'am.
could I please have Emily Baldwin to the main office?
Yes, ma'am.
Thank you.
It's be -3 square root of 10 over 10. All right, and so, Sydney, when we do secant, we could flip this one we just got, or we could look at the original one, and that would be square root of 10 over -3. Are y'all okay? For real, for real? Did I lose anybody? All right, last two. Tangent. What's tangent?
1 over -6.
Very good. It'd be 2 over -6, which is -1/3. All right, what about cotangent?
3 over, no, just -3.
Just -3. Very good. All right, y'all try 3 real quick. 3 is easier because it doesn't have any radicals in it. You're welcome. And then we'll do the bottom 3 because there's a couple of, at least one on the bottom 3 that's a little tricky. All right, so y'all try number 3.
was on. Yeah, whether last testing. Oh wait, that's a net. Base and cost. No, we're gonna do those together. Just do it first.
Some people are still working though.
That's presented.
Math. All right, did y'all get that your hypotenuse was 17?
See? So is she working on sign for 17 yet? Yeah, but pretty nice, guys. Pretty nice.
All right, what'd y'all get? Let's see. Gracie, what'd you get for sine?
Negative 15 over 17.
Very nice. Because remember, theta's right here. All right, Sydney, what'd you get for cosine?
4 to 9. Is that wrong? Wait. No, dang it.
8.
Okay, so I'll tell you what happened. I actually wrote 18 instead of 17.
Oh, well, in that case, you would, yep, and it would reduce in that case.
8 over 17.
There you go, very nice. Madison, what'd you get for tangent?
It would be 15.
Negative 15.
15 over 8.
Perfect, very good. All right, Brinkley, what would the cosecant be?
17 over 9.
Perfect. Josh, what would be the secant?
17 over 8.
Perfect. And Alyssa, what would be your cotangent?
Negative 8 over 15.
Very nice. Y'all okay? That looked really, really nice when I walked around. All right, let's do number 4 together. Number 4.
Whoa.
Yeah, exactly.
There's a
I saw
zero.
it too.
I know, I was just waiting for people to, some people are finishing up 3.
So we just put no solution.
What?
I have a 0.
That's why we're doing it together. All right, are y'all finished on 3? Anybody need a minute on 3?
Where's the X?
Okay, all right, here we go. First things first. Let's draw a graph. Y'all okay so far? Okay. All right, and so then we would have 0, negative 2 would be down here, right? Okay. Good to go?
Yep.
All righty. So you have to think about the angles that we started doing. Where do we start drawing our angle around to make, remember like on Friday before spring break and then yesterday when we did the angles?
Oh, you gotta go left.
There you go. You got to go up and left, right? You start right here at 0 degrees or the same as 360 degrees and you would go all the way around, right? So you're starting right here. So this would be the first part of your triangle and this would be the second part of your triangle, correct? And then you connect them. Y'all okay so far?
Sure.
Now, I'm only showing you this once. Every other time, you're going to know that if you have a point down here, your sine and cosine are always going to be 2 special numbers when you have this 0 like this landing on one of your axes. Does that make sense? Okay. All right, here we go. So first things first is you know that your x is how much? 0. And you know your y is how much? -2. So you could find this hypotenuse, this r, by doing 0 squared, there you go, plus -2 squared equals your r squared. Thus 4 equals square root. And Matthew is correct. R equals 2.
Whoa.
Are y'all okay so far?
Mm-hmm.
Okay. After we do this, every single time, sine and cosine will always be two certain numbers. And you'll see when we do it. All right, so here we go. So sine of theta
Two over negative.
2 over -2 would be how much?
Wait. No, it'd be 2 over 2. Because the hypotenuse and the opposite is the same thing.
Oh, no. Okay, hold on a minute. Your right angle is right here on this one. So this one's different. Your theta's right here. I'm sorry I didn't draw that in. That would help if I drew that in. I'm sorry, guys. Sorry about that.
Okay.
So is your theta always going to be...
It's always going to be at the origin except for when this case happens. But you don't ever have to worry about doing this because once we figure out what you see that sign is always going to be, -1, when it falls down here. Always. Well, yeah, I did my signs backwards, didn't I? Oh, well. There we go. Doesn't really matter, but it does matter to make sure y'all don't get confused. All right. So, what would cosine be? What's your adjacent? 0 over 2, which is just. So, every single time when we do that unit circle project tomorrow and we draw and we create our own unit circle, every time down here, what is this degree measure? 270. So when you have 270, what's sine and cosine? -1 and 0. When you have 180, it's going to be -1 and 0, just in a little different order. When you have 90, it's going to be -1 and 0, just in a little different order. Does that make sense to everybody? Well, it's going to be +1, 0 up here. I'm sorry. All right, so let's do tangent. -2 over 0. Is that possible?
Yeah.
So, Matthew, that one is undefined. But only that one. Well, not only that one. There's one more. All right, what's the opposite of sine? Cosecant. And if you flip it, you would get 2 over -2, which is still -1. And what's the opposite of cosine? Secant, which is undefined, because you would get you would get 2 over 0, which is undefined. Very nice. All right, what about, let's see, the last one's cotangent? My thetas were these. What'd you get? 0 over -2, which is just 0. Y'all okay? All right, let's do,
Whoa.
what?
Oh, never mind.
What?
Never mind. I was
You
gonna
okay?
say it's the same thing, but then undefined is 0 or change.
Some of them are the same thing, yeah. Their opposites are not the same. All right, let's do number 5 together, and then y'all do number 6. Here we go. You ready? -9 and -3. Where do those lie? Third quadrant. Very good. And it's perfectly okay if you don't draw your triangle to scale, especially to give yourself some room. So now your theta is where it usually is, at the origin. And your x is how much? -9. And your y is -3. Okay, so do your Pythagorean theorem. So 81, no, this is 81 plus 9.
So it's 10.
So it's 90. All right, what's the perfect square that goes into that? 10 is not a perfect square. 9, it'd be 9 times 10. Very good. I know. That's why I'm doing this one with you. And then you're going to do one on your own. It's a radical. It's not even what we're talking about.
I know.
All right. What sign? Negative square root. Very good. So how do we find that to start with? What sign?
-3 over 3.
Very good. And the 3's cancel out, leaving us with -1 over square root of 10. And if you multiply by square root of 10 on top and bottom, you do indeed get negative square root of 10 over 10. All right, let's go ahead and do cosecant to make it easy, okay? Let's go ahead and switch it. So we're going to switch this beginning one that we started with. It's going to make our lives easier. So we switch this, and the 3's cancel out still. Very good. Very nice. Very nice. All right, what about cosine of theta? What's cosine of theta? Very good. Very nice. So it would reduce to -3 over square root of 10. And then when you multiply by square root of 10, you do get -3 square root of 10 over 10. Very nice job. All right, what's the opposite of cosine? Secant. Very good. It would be square root of 10 over -3. Very good. Or negative square root of 10 over 3. Doesn't matter the order. I know. I'm doing the opposites. All right. So tangent. What's tangent of theta?
1/3.
How'd you get that?
Because it's -3.
Very good. So it would be positive 1/3. Very nice job. Very nice. All right, and then y'all try 6 real quick, and then we'll call it a day.
You like these? That's my favorite part. Pretty easy. You did take this last time. The days on this app. If you need to, make the triangles pretty big. I know some people are trying to squeeze that stuff in.
All right, let's check your work. You ready? All right, Sydney, did you get sine of theta? Sine. You got how much? So it would be opposite, which is -2, over hypotenuse, which is 2 square root of 5. Then the 2's cancel. And you multiply by square root of, I just don't think you said the square root.
Yeah.
So did you get negative square root of 5?
Yeah, that's what
Okay, all right, cool. All right, so let's see. Diego, what would be your cosecant then? Perfect. Very nice. All right, Josh, what would be your cosine?
2 square root of 5 over 5.
Very nice. So that would be... Okay, so then Seth, what would be your secant?
Square root of 5 over 2.
Perfect. Very nice. All right. Sarah, Avery, do you have tangent? You still working? Negative. Very good. So it'd be -2 over 4. Be -1/2. And let's see. Who am I calling? Emily, what'd you get for cotangent? -2. Very nice. Y'all okay on this stuff? Look, y'all's papers look very nice when I was walking around. Very nice. All right, so what are we doing tomorrow? Project with a unit circle. Building our unit circle. We're in cutting and gluing. So bring your paper. I mean, not your paper. Bring your glue sticks and your scissors if you got them. What are we doing Thursday? Review. And then what are we doing Friday?
Nothing.
Yes, we are doing something Friday. What are we doing Friday? Test. Huh? Not all of you. Not all of you will be absent.
Okay.
Yes, dear.